everybody, Himanshu this side. So welcome to the new chapter of class 10, which is electricity. So before this, you guys had two chapters on the light. So first chapter was about reflection and refraction, and then second chapter was about the human eye. And apart from that, you have also seen the prism as well. So this is now completely new branch, a new unit you guys are going to study in the grade 10, which is the electricity. And after this, we are going to have one more chapter, which is the magnetic effect of electric current. So mainly we have these four chapters, and apart from that, we have sources of energy as well. So now in the electricity chapter, what all we are going to discuss? So our major portion would be the Ohm's law, which we are going to discuss in the lecture number 2 and 3. So lecture number 2 and 3 is dedicated for Ohm's law only. And to understand Ohm's law, we need to understand few basic terms as well, like electric current. Then we need to understand what is potential difference and these kind of terms. So before I go with that part, let us first of all begin with the some basic topics. So what are those basic topics? So here they are. So first of all, we'll discuss about the charge, and then we'll talk about the various charging method, and then potential difference. So these three topics I'm going to take in today's class. Now, basically, in the grade 9, if you recall, then most of the discussion which we had was about mass. It was about mass. A particle is moving, a truck is moving, a body is going from this place to another place. So basically, the entire discussion was about masses only. We have been not been talking about charges. All right. So between mass bodies, we know that there is a force acting which is known as the gravitation force. Similarly, there is a one more intrinsic property which is there in every material, which is called the charge. And this was observed by some experiments only, right? So two bodies were repelling each other. If they are repelling each other, then gravitation force cannot be responsible for it, because gravitation force does not allow the repulsion, it only allows the attraction. So what can be the reason behind this? That means there is some other property which we don't know, which we are missing so far. So there comes the role of charges. So charges are responsible for that repulsion. At the same time, charges can also make the bodies to attract each other, because we know that gravitation force is a very small force if you talk about the simple two bodies of 5 kg, 10 kg masses. Its value is very big when we'll talk about the celestial bodies. Like if you talk about two different planets, then they are very heavy. Between two stars, they are very heavy. So there the gravitation force has a very huge value, and that is what brings the impact as well. Similarly, if we talk about this part, charges can be attractive or repulsive in the nature. It is not like charge force is always attractive in the nature or always repulsive in the nature. It will depend on which two bodies it is acting, and this value can bring a huge impact or huge force. Even a small charge can bring a large force on a bodies. All right. So gravitation force is usually we discuss for the heavy particles which are far away from us, like which are having a very huge masses. So for those things, the gravitation force is giving us the appreciable values. Okay. So now let us begin without wasting any more time. Properties of charge. So charge is basically, we know now that it's an intrinsic property of every material. So now charges are of two kinds. One is called the positive charge, and another is called negative charge. I hope you know this from the grade 8 also. So one is called the positive charge and another is called the negative charge. This positive and negative just nomenclature. All right. And positive, we know that it is showing the deficiency of electrons, cations, which we show basically. And negative means the efficiency of electron, something which has more number of electrons than positive charge. That is called the negatively charged body. Now, this naming was done by Benjamin Franklin. Some basic things I'm telling you in the beginning. Okay. Now the another part is properties related to the charge. So first property is that if two charges are of similar type means one body of positive charge, another body of positive charge, or one body of negative charge, another body of negative charge, they will always repel each other. So here you can see in this example, we are bringing this positive body, and this is a positive body, that's a negative body. So positive and positive are getting repelled from each other, and negative and positive are getting attracted from each other. So like charges repel, and the positive opposite charges attract each other. Second property, which is the quantization of charge and conservation of charge also. Now, what is the meaning of quantization of charge? So quantization of charge basically represents like this. Suppose we have any material, any atom you talk about. Let's talk about the sodium atom. Now, sodium atom has 11 electrons. All right. So what does this quantization of charge says? That quanta means discrete unit. Quanta does not mean the continuous unit. All right. So quantization means the charge is quantized. Like you cannot say that Q is equal to 2e by 3. That is not possible. 2/3 of electron. This much charge is not possible. The charge can be in the integral multiples of electronic charge. The charge can be in the integral multiple of electronic charge. 1 electron can be there, 2 electron can be there, like 2.5 electrons saying is not a good idea. All right. So charge is quantized. That's what the meaning of quantization of charge. Now, after this, conservation of charge. So basically, quantization is simply what did it tell us, that quantization means charge cannot be in the fractional multiple of electronic charge. It would be 2 electron, it would be 3 electron, like that. It cannot be the fractional of electronic charge, because charge can be taken out or can be given to the system in terms of in units of electronic charge only. Now the next part is conservation of charge. So charge is conserved also. So suppose if you have one body, like as they have shown here in the example, this is the body of charge Q. Now, just a second. So this is the body of charge Q. If we take out some charge from the body, Q1, Q2, Q3, right? So Q1 charge you have taken, Q2 charge you have taken. Like let's say you have broke this body into three parts. One is having charge Q1, another is having charge Q2, third is having charge Q3. So ultimately the total charge Q1 plus Q2 plus Q3 would be equal to Q only. All right. So basically, what does it mean? That charge is always quantized. It is not like that. Charge is always conserved. It is not like if it has a total charge of 10 coulomb. By the way, unit of charge is coulomb. Okay. So if I'm saying that total charge of a body is 10 coulomb, now if you break into three parts, then 2 coulomb, 4 coulomb, and this would be again 4 coulomb. It won't be like that. The total sum won't be coming out to be equal to 10 coulomb. Total charge must be conserved. It has to be conserved. All right. Okay. Now the next topic is like, now we know that, okay, what are charges, what are their methods, what are the properties. Okay. And like charges repel each other, and opposite charges attract each other. Now what are the various methods of charging? That's what we are going to discuss now. So there are three methods which I'm going to discuss with you for charging. First is charging by friction. Second is charging by conduction. And third is charging by induction. So one by one, we will discuss all the three methods. So let us see first method, which is charging by friction. So what does this charging by friction says? Like suppose we are, this is having a lot of examples we have seen in our day-to-day life also. Like many times you must have felt that when you make your hair with the comb, and after that, if you, just a second, yeah. And after that, if you bring that comb near the piece of papers, then you will find that that piece of paper is getting attracted by the comb. All right. So basically, when we bring a comb near the piece of paper, it would be attracting those papers. You can do this with scale also. You take one normal scale which you are having and bring that scale near the piece of paper, small piece of paper. It shouldn't be heavy, otherwise you won't be able to see that effect. So take the light small papers, and now first you make your hair with that comb so that it becomes dry, and then you bring those papers near the those that comb near the papers. You would find that those piece of papers are dancing. They're getting attracted by that comb now. Another example. Another example is from, let's say, for a birthday celebration. I don't know whether you have done this or not. Uh, if you want to get stick those balloons on the wall, and if you don't have any glue or something, then what you can do, you take those balloons and now you rub with your hair, and after rubbing it for 30-40 seconds, you stick it on the wall. It will remain there as it is. It will not fall down. So basically, what is the cause behind it? What was that force which was making it to get stick to that wall? Or what was the cause behind those papers? Why they were getting attracted to that comb, or they were getting attracted to that scale, plastic scale? So apart from this, one more example, let me tell you. Okay, so this example is about a glass stick. Suppose we are having a glass stick. Okay, that's a glass stick. And this glass stick, I am going to rub with a silk cloth. So I'm having one silk cloth. That's a silk cloth. Okay. So basically, I have two things: the glass stick and the silk cloth. Now, what will happen if I rub this silk cloth and glass stick together? So what I find is this glass stick will become positively charged, and I find this silk cloth becomes negatively charged. That can be find out experimentally, right? Later on, we can use electroscope or something, or we can bring some other positive charge material. If it is repelling the glass stick, means it has become repulsive. It has become positively charged. If it is getting attracted by that positive charge material, that means the glass stick is basically negatively charged. Okay. So the basic idea is that in every all the 3-4 situation which I have discussed with you, either it was a comb, or it was a scale, or it was a glass silk, or it was a balloon rubbing with the hair. In all these 3-4 cases, we were rubbing two bodies together. So basically, what happens when we rub two bodies together, like here you can see the neutral comb and the neutral hair. So when we are rubbing them together, then due to the due to the friction, the heat is being produced. So basically, we are having some energy which is being produced there, and because of that energy, they are sharing the electrons among with each other. So initially, glass stick was neutral, silk cloth was neutral. But what happened because of rubbing? So by rubbing them together, actually what we did is this silk cloth has taken few electrons from the glass rod or from the glass stick. So this glass stick has become positively charged because this glass stick has already given some electrons to the silk cloth. So now the silk cloth will become negatively charged, and it has given the electron. So this will become positively charged. And this is a basic process happening between all these situations. Either you rub the balloon, it becomes one of the charged. Then either you make your hair with the dry hair with the comb, again it will become charged, that comb thing, and it will attract the piece of papers. Okay, so that is the basic method behind the charging by friction. Now we have another methods also, which is called the charging by conduction. Now the two methods which I'm going to discuss with you, the charging by conduction and charging by induction, they are very close to each other. They looks very similar to each other, but there are certain differences between them. So those 1-2 differences we must remember. It can be asked in our exam as a 1-mark question. So first of all, charging by conduction. Conduction means what? it will be sharing the charge with each other. So suppose what I do, I'm having a negatively charged stick here. So that's a negatively charged stick. All right. And this is a neutral body. This is a neutral body. All right. So if it is a neutral body, then what does it mean? It will be having positive as well as negative charges. All right. So basically, let me draw this separately here. That's a neutral body. So positive, negative, positive, negative, positive, negative, like this. So equal distribution of positive and negative charge, right? That's why we call it neutral body. Second body we are having, that second body is basically negatively charged. All right. So this is neutral and this is negative charged. All right. Let us see what will happen if you bring this negatively charged body near the neutral body. So guys, what you will find that as soon as you bring this negatively charged body in contact with the neutral body, the situation would be like this, the new situation. This negatively charged stick would be coming in contact. Just a second. So now there is a contact between them. Okay. So that's a neutral body and now they have come in the contact. But guys, now you will see one thing. As soon as you bring them in contact, you will find that by this negatively charged body or this negatively charged stick, the negative charge or the electrons of this neutral body will get repelled. I'm right? Yes, because negative and negative will repel each other. And the positive charge will accumulate on the one side. So basically what will happen? All the negative charge will get replaced away from the body. And what about the positive charge? This positive charge will come on the other side. And now because this body is in contact, this negatively charged stick, it is in contact. So this positive charge will get transferred to this negatively charged body. And now when you remove the contact, what will happen? As soon as you remove the contact, if you look at this negatively charged body, because it has given some positively charge to the another system, all right, it has given some positive charge to the negatively charged body. The positive charge has been transferred from here to here. This will become, because now it will have less positive and more negative, because positive charge has been transferred to the negatively charged body. So final situation, what will be happen? They will get now equally distributed, and yes, the axis would be of negative charge now, because the positive charge has been already lost by this body. Similarly, if you bring a positively charged body, instead of this negatively charged stick, you bring a positive charged stick. So negative will be transferred to this positively charged stick, and the body will remain more positive now. In that way, you can make the body positively charged. So right now we have made negatively charged. Similarly, you can also make negative charged to the body, or positive charge to the body. So that's the basic uh, method by which we can charge the body with the help of conduction. Conduction means there was a contact. Now, the third example is charging by induction. Now, in charging by conduction, you should see that part very carefully. Let me just erase this positive charges. Just a second. Yeah. So you can see here, we are bringing the negatively charged body close to this neutral body. So the moment they touch it, it becomes negatively charged. All right. So now after that, once they take it back, then that negatively charged will, the moment they touch it, then the positive will be transferring to this body from here to here. And the moment they will bring it back, like when they will release the contact from here, the negative charge will get equally distributed into this. All right. So after touching, it will become negatively charged. Now, similarly, there is one more concept by which we can charge the bodies, which is called the charging by induction. Now, what is charging by induction? So the basic difference between conduction and induction is, in the method of conduction, there was a contact. But in the case of induction, there will be no contact between the charged body and neutral body. No contact. And here this C stands for contact. That's how you can remember. That's the very confusing part. Many times we forget that which one was induction and which one was conduction. Though we know that in one of the method we are making in contact, in the another method we are making them to not come in contact. But how to remember this? So in the conduction you have C. So that C, you can say it stands for contact. That's how you can remember it. Now what happens in the case of methods by induction? So when we charge the body by induction, again I'll bring the negatively charged body, or you can bring the positively charged rod also. That is your choice, what you want to make the charge on the neutral body. And this is the neutral one. So step number one. Certain steps I'm going to follow here. Step number one. Step number one says that you bring the negative charged body near the neutral body. You don't have to touch it. You just have to bring it near. So when you do so, what will happen? When you bring the negatively charged body near the neutral body, what is the case? What we will see? We will see that this side will become positively charged and this side will become negatively charged. Why so? Because negative charge is coming closer to the body, neutral body. So positive charge will be getting attracted to it. They'll get attracted to it. But they will not be able to transfer. They'll not be able to escape now because there is no contact between them. In the case of conduction, there was a contact. So positive charge will come closer on the one side and negative charge will be getting repelled. So they will go on the other side. So now basically guys, what will happen? This side has become positive charge and this side become negatively charged. Now, if you bring that negatively charged rod there for some time, if you keep it at this location for some time, those positively charged will not be able to go anywhere else because now they are in the influence of these negatively charges. They cannot escape now. So what do we call them? These are known as bound charges. Bound charges. They cannot go anywhere now. They have been bounded with this negatively charged rod. And these things can go anywhere. So they are called free charges. So methods are clear. Step one, bring the body closer. Step number two, you will find that one side has become positive, one side has become negative. All right. Now there is a distribution of charges. One side is a bound charge, other side is the free charge. Now what you will see that the bound charge cannot go anywhere and neutral charge is a free charge. Basically, it can go somewhere if you make it to go. So now what I'll do, I will connect the step number three or two. Now I will connect this end. Let's say this end is A and this end is B. Now what I'll do, I'll connect this B end with the ground, which we called earthing. Now earth is a very big conductor. It has a very huge capacity. If you connect that negatively charged end to the earth, that negatively charged will get transferred to the earth. It will get transferred to the earth. So now what you will find, guys, that the negative charge has been transferred to the earth, means it has lost some negative charge. So what will happen? It will become positively charged. So this neutral body will not be no more neutral now. It will become positively charged. Similarly, if somebody brings a positive charge rod near the neutral body, the negative will become bound charge because now they are attracted. and positive will become free charge. So positive will be transferred to the earth in this case. All right, if you connect it with the earthing. So in the charging by induction method, there is a one more step which we need to take care of, which is the earthing part. And there is no contact we need to make. So that is the basic difference between charging by conduction and charging by induction. All right. Now I hope all the three methods of charging are clear to you. And we have learned what is an electric charge. All right. That's another property, just like mass we have discussed. It's another property we are discussing in this chapter. Now I'll go ahead with the new term, which is called the potential difference. So what is potential difference, and what does it explains, and why it is important? So for that, I am going to take first of all one analogy. So this analogy is about this water transportation system. You must have seen that in our at our house we have those water tanks, and are kept at a very certain height. Let's say third floor or fourth floor of the house. So why do we keep it at a certain height? The reason you all know very well. The reason is, if you keep it at the same horizontal level, then the water will not transfer from the tank. So suppose if we keep the tank here only, and we have the tap at this portion only, so at this height the water will not be transferred to this tap. All right, because there is no pressure difference. If you remember from the grade 9, what do we say? That the pressure difference is very important if you want to transfer the water from one place to another place. So, and water goes from high pressure to low pressure. Similarly, here also, I have taken the same example. We have two bottles here, bottle 1 and bottle 2. Now, bottle 1 is having liquid up to a certain height h from here, and the bottle 2 is empty right now. So if you now, in this case, what will happen? At this end, we know that the pressure is atmospheric pressure, because here we have the air. So this will exert the atmospheric pressure. And at this place, the pressure which we'll be having, it will be P naught plus rho GH. If you know, rho is density, H is the depth. So when we go down, the pressure increases. So P naught plus rho GH is the pressure there. Now, guys, what will happen? That is very interesting. So what we will see now, that if the pressure is P naught plus rho GH at this end, so at this place we have the pressure P naught plus rho GH. At this place we have the pressure P naught. Now, because of the high pressure, and this is a lower pressure, we have connected them through a pipe. So what will happen? This water will start flowing through this pipe in this bottle. All right. So water will start transferring from this bottle to this bottle. And with time, what you will find, that this bottle 1 water level is decreasing. It will keep going down. And the water bottle 2 level will keep going up. And a time will come when their level will become same. So in that situation, what will happen? Once their level becomes same, no more water flow would be there. So if you take two water bottles in which the water level is up to the same height, then no more water transfer will take place. Yes, if you make some height difference in the water bottles, then the water transfer will keep taking place until this height becomes same. Okay. So that's how this pressure, because of pressure difference, we make the water to flow from high pressure to low pressure. Similarly, if I talk about a wire, so suppose let's say we are having this wire. Now in this wire, it's a metallic wire I'm taking, some copper wire you can think of, or you can think of some nichrome wire. It's a metallic wire in which we have some free electrons. So these are the free electrons. Now what do I mean by free electron? Free electron, I mean that they are no more in the influence of that copper nucleus. If it is a copper wire, the nucleus cannot stop these electrons to go away from it. So they can easily revolve around this entire thing, around the wire, inside the wire. So basically, guys, now what will happen if you keep the wire in this situation? These electrons, if they are kept at the room temperature, this wire is kept at the room temperature, these electrons will be in the random motion. Now, what do I mean by the random motion? Zigzag motion, you can say. Because of the thermal energy, they will be having some temperature outside around 20-30 degrees Celsius. So at the room temperature, they will be having some thermal energy available. And what do we know about electric current? Electric current is basically the total charge flowing per unit time through a given cross section. That is called the electric current. Now, if you see one thing, if you talk about this particular cross section here, now from this particular cross section, the number of charge particle which will cross are equally probable. Let's say 10 electrons are going this side, then there is a good possibility that 10 electrons will go this side also. So on an average, if you see, the electric current is come out to be zero when the wire is kept normally in the at the room temperature. So just because of thermal energy, you cannot get the electric current from there. So what you need to do if you want to have the motion of this charged particle in a certain direction, because motion of charged particle gives you the electric current. So now for that, as I gave you the analogy before, that we will have two water bottle system. Here we use a device called a cell. So what this cell is about, in this cell, there is a chemical energy, which you have discussed in the chemistry also in the redox reaction chapter. So because of the redox reaction between between the electrode and the solution, one end of the electrode becomes positive and other end of the electrode becomes negative. So one end is positively charged of the electrode and other end is the negatively charged electrode. And now we have the solution also here. This is the electrolytic solution. So this happens because of the redox reaction. I'm not going into the detail part of it because that is the chemistry part. So two redox, now different electrolytic cells are possible there. So one is positively electrode and another is negative electrode. Because of this, we will have some difference of charge there. So one side is positive and one side is negative. Now what will happen? This is called a cell basically, which we denote by the symbol this. Battery is basically combination of cells. When we have more than two cells, we call it a battery. More than one cell is they are connected together. That is we call a battery. I hope you have done this in the grade 8 also. Now, what we have seen, what is the main problem with this wire? That when we do not connect this wire with when we do not connect this wire with anything else, then the electron would be in the motion because of thermal energy, but that would be totally random motion. And from that motion, nobody can get the electric current. If you want to get the electric current, then you need to make these electrons to go in a certain specific path or like this. And for that, what you need to do, you need to connect them with a cell. So guys, what this cell will do, let us discuss now. That's a symbol of cell. This is representing the positive side. This is representing the negative side. Positive means the uh, it's positively charged electrode. Okay. Let us see what will happen. So again, we had the same wire and in which we have these electrons present in the wire, which will be in the random motion because of the thermal energy. And now I have connected them through a cell. Now you know very well, this is the positive end and this is the negative end. So what will happen? These electrons will keep flowing and they will be attracted to the positively charged of the body. So this electron will get attracted to the positive terminal. So this electron will start from here and they will revolve around this circuit like this. So they will go in this particular path. Now they have become oriented or we have made them to go in a certain specific path only. They are in the random motion because of thermal energy, but now we have provided them some extra energy from outside. This is the extra energy which we have provided. So what is this extra energy in the form of? It is in the form of chemical energy. Which chemical? These were the chemicals. So this chemical energy is being converted into electrical energy. All right. So this chemical energy we are utilizing to make the motion of charged particles. Now these electrons will become in a particular direction oriented, because now they are supposed to get attracted by the positive electrode. And because of that, the current would start flowing in the opposite direction. Because we know that if electrons are flowing in this direction, then current flow is opposite to that. Electron flow is showing the electronic current. But for our calculation purpose, we take this as the conventional current, opposite direction, because we assume that the positive charge is the motion of positive charge. The direction of positive charge is basically the electric current. It is just a, like, electron is going this side, we can say that positive is going this side. If electrons are going this side, means deficiency is happening here, means positive charge is going this side. So that's why this is the direction of conventional current, and that's the direction of electronic current. All right. So electronic current we do not consider, we consider the conventional current only. But main reason is electrons only. So electrons are going in the clockwise, anti-clockwise sense, but current would flow in this sense. All right. So that's how the current would start flowing. Now this was at the the positive electrode, and this is the negative electrode. So this is what we call the potential difference, right? So this is called one of the potential, the positive terminal, and this is called the negative terminal. So this is the high potential, high voltage, and this is the low voltage or low potential. So potential difference we need to maintain. If you do not maintain the potential difference, then then the electrons will not go in a certain path. So similarly, if you take a wire, all right, and now if you connect that wire with the battery, then what that this battery does, basically, it does not provide the charges. Charges are already inside the wire. Battery do not provide the charges. Battery basically provides the potential difference, and that potential difference will make the charge particle to flow in a certain path. That's what we call the electric potential. All right. So now this is the battery, and if I say this potential difference is delta V. So what is this delta V? How it is defined, the potential difference? It is defined as the total amount of work is being required per unit charge. That is what we call the potential difference. So total amount of work required to move the charges per unit charge. It's called the potential difference. Okay, so work involved or the energy released in the transfer of unit quantity of electricity from one point to another. Now, so it is just like the electric water bottle, that we need to maintain the potential difference to have the motion of these charged particles. Okay, let us do one question from NCERT. How much work is done in moving a charge of 2 coulomb across 2 points? So work done is basically delta V multiplied Q, because just now we saw that delta V is nothing but W over Q. How much potential difference we need to maintain? It is 12. In moving a total charge of 2 coulomb, so 12 multiplied 2 is 24 joules. That's the final answer. Okay, so that's how we will get the answer of these type of questions whenever we get potential based question. So potential difference is basically those positive and negative electrodes difference. Okay, and we need to maintain it to have the motion of charged particles. Similarly, one more question. State the relation between work, charge, and potential difference for an electric circuit. Okay, so that's we have just done just now. It is nothing but delta V is equal to W over Q. Calculate the potential difference between the two terminals of the battery if 100 joule of work is done to transfer a total charge of 20 coulomb. Very simple question. 5 volt. So unit of potential difference is volt. So that's how I'll be writing it. Okay, so there also you can see the symbol which we have been using was V, capital V, or you can say 5 capital V. So that's how we'll be solving the questions related to the potential difference. So guys, in this session, we have completed the basic part, and the next session also will be discussing one more property, which is called resistance. So after that, you will be able to understand the Ohm's law, which is the most important thing of this chapter. So guys, that's all for today. Now be connected for the next lecture, because in that lecture we'll discuss one more property. And I hope you have understood the lecture. If any confusion, just put it on the PDF. Thank you so much. Bye bye.